The National Electrical Code, or NEC, Article 250 covers grounding and bonding requirements. Section 250.56 specifically addresses the grounding of electric fences. Paragraph A, where required, states that electric fences must be grounded according to this section when the fence is within 10 feet of a building, swimming pool, or other structure accessible to persons, or within 5 feet of a travelled area. Paragraph B, common grounding electrode, mandates that all electric fences be grounded to a common grounding electrode system. This grounding electrode system must comply with Article 250, Part Roman III. Section 250.58 outlines prohibited grounding connections. Paragraph addresses water pipes, prohibiting grounding to interior metal water piping systems. Grounding to the exterior metal casing of underground water piping systems is permitted if the grounding electrode is listed for use with water pipes. Paragraph B addresses gas pipes, prohibiting grounding to interior or exterior metal gas piping systems. In summary, when installing an electric fence, firstly, ensure that it is grounded if it falls within 10 feet of structures accessible to people or within 5 feet of travelled areas. Secondly, use a common grounding electrode system that adheres to Article 250, Part Roman III of the NEC. Thirdly, avoid grounding to interior metal water pipes for any gas pipes, and use a listed grounding electrode if grounding to an exterior underground water pipe casing. For additional information, refer to IEE Standard 1100-2018 Guide for Grounding of Industrial and Commercial Power Systems and UL Standard 503 Standard for Electric Fences. These standards provide more in-depth guidance on grounding practices and electric fence safety. Adhering to these NEC guidelines and consulting the additional resources ensures a safe and compliant electric fence installation. Remember to always consult with a qualified electrician for any electrical work to guarantee safety and compliance with local codes. Correct grounding is essential for the safe and effective operation of electric fences. The National Electrical Code provides specific requirements for electric fence grounding to minimize the risk of electrical shock and ensure proper operation. Always follow these requirements and seek professional assistance when needed. Grounding an electric fence is critical for safety and proper functionality. It ensures that the electric current flows correctly, providing the necessary shock to deter animals or unauthorized access while minimizing the risk of harm to people and pets. The grounding system acts as a return path for the electrical current, completing the circuit. A properly grounded electric fence will deliver a more effective shock compared to one that is poorly grounded or not grounded at all. The grounding electrode, typically a ground rod, should be made of a conductive material such as copper or galvanized steel and driven deep into the earth to establish a reliable electrical connection. The size and number of ground rods required will depend on factors such as soil resistivity and the length of the fence. Soil resistivity is a measure of how well the soil conducts electricity. Soils with high moisture content and high mineral content generally have lower resistivity, making them better conductors. Sandy or rocky soils, on the other hand, tend to have higher resistivity. To ensure adequate grounding, it may be necessary to install multiple ground rods spaced apart from each other. The NEC specifies the minimum requirements for grounding electrode systems, including the size and type of ground rods, as well as the methods for connecting the grounding conductor to the ground rod. The grounding conductor, typically a copper wire, must be of sufficient size to handle the expected fault current. It should be securely connected to the ground rod using a listed connector. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Check the ground rods and grounding conductor for corrosion or damage, and replace them if necessary. Also, test the grounding system periodically to verify its resistance to earth. A low resistance reading indicates a good ground connection. High resistance indicates a poor connection that needs to be addressed. When installing an electric fence, consider the surrounding environment and potential hazards. Avoid installing the fence near flammable materials or in areas where there is a risk of explosion. Also, ensure that the fence is properly marked with warning signs to alert people to its presence. If the electric fence is powered by a solar panel or other renewable energy source, the grounding system must be compatible with the power source. Consult with a qualified electrician to ensure that the grounding system is properly designed and installed. Improper grounding can lead to electrical hazards and equipment damage. The NEC prohibits grounding to interior metal water piping systems because these systems are often connected to other metal structures within the building, creating a potential path for stray currents. Grounding to gas pipes is also prohibited due to the risk of igniting the gas. These restrictions are in place to protect against electrical shock and fire hazards. While grounding to the exterior metal casing of underground water piping systems is permitted under certain conditions, it is essential to use a grounding electrode that is specifically listed for use with water pipes. These electrodes are designed to withstand the corrosive effects of the water and soil, ensuring a reliable ground connection. The IEE Standard 1100-2018 Guide for Grounding of Industrial and Commercial Power Systems provides comprehensive guidance on grounding practices for a wide range of applications. It covers topics such as grounding system design, equipment grounding, and lightning protection. The UL Standard 503, Standard for Electric Fences, specifies the safety requirements for electric fence controllers and accessories. It covers topics such as voltage limitations, insulation requirements, and grounding requirements. Both of these standards are valuable resources for anyone involved in the design, installation, or maintenance of electric fences. Electric fences are commonly used in agriculture to contain livestock and protect crops from wildlife. They are also used in security applications to deter intruders. The design and installation of an electric fence will depend on the specific application and the type of animals or intruders that the fence is intended to deter. In agricultural applications, the height and spacing of the wires will need to be adjusted to suit the size and behavior of the animals being contained. For example, a fence used to contain cattle will typically be taller and have wider wire spacing than a fence used to contain sheep. In security applications, the fence may be equipped with additional features such as alarms and sensors to detect breaches. The voltage of the electric fence controller should be selected based on the type of animals or intruders that the fence is intended to deter. Higher voltages are generally more effective at deterring larger animals or determined intruders. However, it is important to avoid using excessive voltage, which could cause injury or death. The NEC specifies the maximum allowable voltage for electric fences. Always follow these voltage limitations to ensure safety. When working with electric fences, always take appropriate safety precautions. Wear insulated gloves and boots to protect against electric shock. Disconnect the power to the fence before performing any maintenance or repairs. Never touch the fence wires while the power is on. Be aware of the potential hazards associated with electric fences and take steps to minimize the risk of injury. Electric fences are a valuable tool for controlling animals and protecting property. However, they must be installed and maintained properly to ensure their safe and effective operation. By following the NEC guidelines and consulting the additional resources mentioned, you can minimize the risk of electrical hazards and ensure that your electric fence is working as intended. The effectiveness of an electric fence relies heavily on a properly installed and maintained grounding system. The grounding system provides a low resistance path for the electric current to return to the energizer, completing the circuit and delivering the intended shock. Several factors can affect the performance of the grounding system, including soil type, moisture content, and the number and placement of ground rods. Sandy or rocky soils tend to have higher resistance than clay or loam soils, making it more difficult to establish a good ground. Dry soil also increases resistance, so it may be necessary to water the ground around the ground rods during dry periods to improve conductivity. The number of ground rods required will depend on the energizer's output and the soil conditions. As a general rule, it's better to have more ground rods than fewer. Ground rods should be spaced at least 10 feet apart to avoid interfering with each other's grounding field. They should be driven deep into the ground, typically at least 8 feet, to reach moist soil. The grounding wire, which connects the ground rods to the energizer, should be made of a heavy gauge, corrosion-resistant material such as copper or galvanized steel. The wire should be securely connected to the ground rods using clamps or connectors designed for grounding applications. Regular maintenance of the grounding system is essential to ensure its continued effectiveness. Check the ground rods and grounding wire for corrosion or damage, and replace them if necessary. Also, test the grounding system periodically using a ground resistance tester. A reading of 25 ohms or less is generally considered acceptable. If the resistance is higher than 25 ohms, additional ground rods may be needed. In addition to the grounding system, the electric fence itself should be properly constructed and maintained. The fence wires should be tightly stretched and securely attached to the posts. The insulators, which prevent the current from leaking to the ground, should be in good condition and free of cracks or damage. The vegetation around the fence should be kept trimmed to prevent it from shorting out the fence. Electric fences can be powered by various sources, including AC power, DC power, and solar power. AC-powered energizers are typically used for larger fences or in areas where electricity is readily available. DC-powered energizers are often used for portable fences or in areas where electricity is not available. Solar-powered energizers are a good option for remote locations where there is plenty of sunlight. Regardless of the power source, it's important to choose an energizer that is appropriately sized for the fence. The energizer's output, measured in joules, should be sufficient to deliver a shock that is strong enough to deter the target's animals or intruders. However, it's also important to avoid using an energizer that is too powerful, as this could cause injury or death. The NEC provides guidelines for the maximum allowable output of electric fence energizers. When installing an electric fence, it's important to consider the safety of people and animals. The fence should be clearly marked with warning signs to alert people to its presence. The signs should be placed at regular intervals along the fence and at gates or other access points. The fence should also be installed in a way that minimizes the risk of accidental contact. For example, the fence should be set back from roads or walkways, and it should be equipped with a gate that is easy to open and close. Electric fences can be a valuable tool for controlling animals and protecting property. However, they must be installed and maintained properly to ensure their safe and effective operation. By following the NEC guidelines and consulting the additional resources mentioned, you can minimize the risk of electrical hazards and ensure that your electric fence is working as intended.